Hello everyone, my name is Shahid. Today I will be conducting a seminar on the topic data intensive computing under the guidance of Sudha ma'am. First, what is data intensive computing? Data intensive computing is used to process large amount of data. It is all about, in a simple words, it's all about dealing with a lot of data. This data can range from 100 megabytes to petabytes. Just for a scale reference, 1 petabyte is 1,000 terabyte. So the computing ranges from a small amount of data to even a massive amount of data. Datasets is an important part of data intensive computing. It is referred to a bunch of information that is important for one application or several applications. The datasets are stored in locations called repositories. Repositories are places where we can keep, find, and organize lots of information and data. Now, since the data is kept in these repositories, we need to be able to organize and search for this. So in order to make it easier to do this, we attach a small piece of additional information, and this additional information is called the metadata. Applications. There are several applications of data intensive computing in our everyday life. The most important ones are used in telescopes, used in earthquake simulators, and used in other computational science applications. For example, in telescopes, scientists run simulations and experiments. They often need to work with huge amounts of data. For example, telescopes take pictures of astronomical objects in the sky, and these images produce hundreds and hundreds of gigabytes of data every second. And for over the course of the year, it can add up and will be huge. So we need to be able to process this data, and data intensive computing is being used in this application. Earthquake simulators generate a massive amount of data by recording vibrations from all around the world. This data is then used by scientists and even engineers and architects to build better buildings to help combat this phenomenon. Characterizing data intensive computations. Data intensive applications handle large amounts of data, and they often need a lot of computing power. These applications work with datasets that can be as big as multiple terabytes and petabytes. So, and this, like we said before, as in repositories, this information stored in different places and locations and in different formats. These applications process the data in multiple steps. So these multiple steps may include transforming the data, then combining the different types of data in order to process it. They also require effective ways to manage, filter, and merge the data, as well as efficient methods for searching and sharing it. The processing needs increase in proportion to the size of data. So the bigger the data, the more processing will be required. So if we break down the data, transform, and then combine it, by splitting the data into several different parts, it will make the processing more easier. Data intensive computing is very widespread, used in several different ways and applications. It has a lot of applications, but there are a few challenges while using data intensive computing. First is that algorithms should be able to search and handle large sets of data efficiently. Since, like I said, the data can range to the range of data is very vast. So it can range from very low to very, very high. So the algorithm which is used by the data intensive computing should be able to search and handle these large sets of data. Technologies to manage different types of data from various sources. So a lot of different technology is used, and these technologies should be used efficiently and properly to handle data that is stored in various different locations. Computing platforms must be improved constantly to handle these large amounts of data. Computers in our everyday life and their architecture is being improved day by day. So this can really aid in computing the data. File systems that store this data must be reliable and fast. There should be no loss of data, and the processing which the file system does, it should be very efficient and fast, because time is a very valuable asset, and data intensive computing requires a lot of time and energy. So if the file system ideally should be able to do this process very very fast. Data size, since the data size is very huge, the techniques should be used to reduce this data size so the process can be sped up. Another way to deliver algorithm to where the data is located should be found. Data in repositories, data is stored in many different formats and many different locations. So new ways to deliver the algorithm to these specific parts must be found. New designs are to be made to handle large data streams from fast networks and scientific instruments. Techniques to quickly combine software modules from different platforms for analysis. There are data stored in many different platforms and it comes from many different platforms. So a technique should be made to combine these data sets from different platforms efficiently into one and be able to process this data efficiently and properly. So this was my seminar on the topic of data intensive computing. So thank you everyone for listening.